A very good evening to one and all present here to all of our viewers. This is Mahi Jumnani, and I welcome all of you to the third Tech Talk of Taqneeq 13.0. So today with us we have the senior data scientist from Nike and Mr. Balaji Kesavan. So Mr. Balaji has over 8 years of experience as a data scientist, working in companies like Mu Sigma, Humana, Microsoft, and Nike. He specializes in hypothesis testing, machine learning, and time series forecasting. Sir, I welcome you here, and I hope the students really appreciate what you do.
Yeah, thank you
So,
for
sir,
having me. Excited to be
yes,
here. The talk I want to give today is called An Intro to Data Science. So let me start sharing my screen and we can take it from there. My talk today is called An Intro to Data Science.
yeah.
I don't want to give you a lot of technical details. I just want to get you excited about data science as you guys are in engineering right now and hopefully will be starting your career soon. So my
Yeah.
goal here is to get you excited about data science. So before I go into my presentation, I want to thank everyone at Taqneeq as well as the Mukesh Patel School of Technology and Management for having me here. So let me dive right in. Okay, so before we go into the data science part of the presentation, let me give you a brief introduction about myself. Like I said, my name is Balaji. I am from India. I grew up in Hyderabad all my life. I did my engineering from NIT Durgapur. So
Nice.
I did my bachelor's in civil engineering. I graduated in 2011. Been about 10 years now. So during my engineering, I had an internship at IIT Guwahati. Again, it was completely unrelated to data science, fully related to civil engineering. I also had a foreign internship at National Taiwan University, again, fully related to civil engineering and nothing to do with data science. However, during my last year of engineering, I got a job at a company called Mu Sigma. I'm sure you guys have heard of it. It's a company,
Yes,
it
sir.
used to be a startup based in Bangalore. It's no longer a startup. But yeah, when I did join it, there are like 500 people, and there was really that startup vibe. This was my first foray into data science. This is where I learned everything about data science. Uh, I had no coding experience before this. It was my first job here. This is where I learned everything. So I worked here for about 2 years. Then I came to the US to pursue my master's in management information systems. Uh, and the reason I chose management information systems and not like an analytics or data science is because back in 2013, there were no data science courses available anywhere
Yes,
in.
sir.
So I chose something that was closest to data science, and at that point in time, it was management information systems. Uh, and then right after that, I worked at a health insurance company called Humana. Again, it was a full data science job. Then I worked at Microsoft for about 2 years. Uh, and then I moved to Nike. Uh, then at Nike, I worked for a little bit in Canada, in Vancouver. But now I'm back here in Portland. So that's a brief introduction about myself. Okay, so let's dive into what a data scientist does. Okay. Um, so I'm not sure how many of you know what a data scientist does, but if you were to just do a simple Google search, these are some of the terms that you're likely going to encounter, right? You're going to obviously machine learning is going to be on top. You're going to learn. You're going to hear about artificial intelligence, neural networks, a lot of different types of analytics. I'm sure you're going to come across business intelligence, reinforcement learning, and there's going to be a lot of it, right? So it is true that a data scientist does all of these, but I like to think that at a more fundamental level, we do something quite different. Right? And that's what I want to talk about today. So let's take a step back and at a much more fundamental level, let's look at how do we make decisions. Right? We as human beings or a corporation or a government, there are, I say, at a very broad level, there are two ways to make decisions. Right? One is, you make completely random decisions and hope for the best. The other extreme of that would be to use your intelligence, experiences, your data, your emotions, and your intuition. So, and what I mean by each of these, I'll go into depth about it. Okay. So first, let's look at what I mean by randomizer decisions. So, a very easy example is a coin flip model. So, for example, you want to have dinner tonight, and you want to choose between rice or roti. Right? You can flip a coin to decide what to have. Right? Um, or you're at a restaurant and you need to pick something off of a menu. You can roll a dice to pick what you want, right? Or let's say you're the owner of the restaurant and you need to know how many kilograms of onion you need to purchase for today, right? Again, you could open up an Excel sheet, do something really fancy but still really stupid. Pick a random number. All of these, I would say, these are a random way of making decisions. And obviously, I think all of us can agree that this is not the right way to make any decision. The obvious right way to make a decision is to use your own intelligence, experiences, data, emotion, and intuition. And this is where I think there is this battle between your brain and your heart. Your brain, I would like to think that it's in helps you make intelligent decisions based on your experiences and data, whereas your heart helps you to make decisions based on emotion and intuition. Uh, and obviously, both of them are really important when you're making decisions. Um, Now, coming back to what a data scientist does is we build systems that help corporations make decisions based on data, right? So the brain part of that decision making is what we do. We build systems that help corporations to make these decisions. Another way to look at it would be to say that we are at the intersection of computer science, maths, and statistics, and domain knowledge about the business. I think this is a really interesting way to look at it, where we are essentially combining three different topics to uh, understand what data science is. So I hope that it sheds some light on what data scientist does. So the next thing that I have here today is to talk about some real world use case, something called hypothesis testing. Right. So before I go into that, I just want to make sure everyone knows what a hypothesis is. A hypothesis is essentially an assumption that I think to put it in a very simple way, a hypothesis is an assumption that you have and you are essentially trying to test whether your assumption is correct or not. Or a hypothesis could be something that someone told you, and you want to test whether that is truthful or not. And a data scientist, I think one of the simplest thing a data scientist could do is hypothesis testing. So I'll give you a really in-depth view of what this is. And I'll also talk about some machine learning and forecasting work that I've done. However, this is the case with all data scientists. We sign non-disclosure agreements with our employers, so we can't, go into too much detail about it. And that is why I've chosen something really simple, which I actually did not work on, and you'll know why. Okay, so there's nothing more real world right now than the pandemic that we are going through, right? And the vaccine is in the news for quite some time now. There is this company called Pfizer in the US, which created a mRNA vaccine, and I'll talk about what that is. The claim that Pfizer has is that the vaccine has a 95% efficacy. Now, the word efficacy, all it means is that it does what it's supposed to do. So to put it simply, it says that uh, there is a 95% chance, or it will reduce your chances of getting infected by the coronavirus by 95%. So before I go into the data science part of it, I just want to give a quick overview of what mRNA is, because I'm not sure if you guys know about this, because the two vaccines in India, they don't use this technology. So again, I'm not an expert by any means here, but this is something I found on the internet about how the mRNA vaccine works. So I hope you are aware by now how the coronavirus infects us. So there is something called the spike protein, which it uses to embed itself into our cells, and then it enters our cell and does its thing. Now, the way the mRNA vaccine works is that it's the M in mRNA stands for messenger RNA. So the messenger RNA is essentially a code that our body can use to create the spike protein itself. So that the mRNA sequence is embedded inside a lipid coating. Again, just fancy terminology for it's embedded inside something, and then that is shot into us. And then once the mRNA sequence is inside our body creates the spike proteins. And then once the spike proteins are created, the antibodies in our body, attack and then learn how to attack the spike protein and how to defend itself. And so once the actual coronavirus comes in to our body, our antibodies are trained enough to identify the spike protein and to tackle it. So that's how it ends up reducing your chances of getting infected. Now, coming back to the data science part of this, right? Um, you know, like there are a number of steps here, and all of this, when a scientist looks at it in theory, um, you know, they know that it's going to work. But the next thing that they need to do is to make sure that it's going to work when you roll it out to, billions of people across the world. So the way they do it is something called trials. I think in the media it's referred to as phase 3 trials, where they select a random population of people, give half of them something called a placebo, which just means just plain water, you're not getting the vaccine, and the other half get the vaccine. They are referred to as the treatment. Okay, so this is what the trial data looks like that Pfizer has released to the public. So about 21,700 people got the control, that is the placebo, and 169 people got infected. Um, when it comes to the people who got the vaccine, again, about 21,700 got the vaccine, and only 9 people got infected. Now, the reason why these 9 people got infected is because, number one, the people do not know whether they are getting the placebo or the vaccine. And moreover, once they do get the vaccine, the people are encouraged to carry on with their life as usual. They're asked to wear their masks, go out, do their job, or if they've already, if whatever the job entails, right? They're asked to behave as if uh, you know just like everybody else in the world. Now, when it comes to how that efficacy calculation is done, it's a very simple calculation, right? Like you just take the percentage of infected and you look at the percentage difference, and that's how you come up with that 95% number. Now, the question a data scientist can come in and answer here is, how confident are we that this 95% efficacy uh, will be there even when we roll it out to everybody, right? Like it's a hardly 45,000 people that were included in this study. How likely is it that when you roll it out to billions of people, that you will still get the same 95% efficacy? So this is where I would say the data science part of all of this comes in. You can already see some of the math, but it's going to get a little heavier in math. Um, and in terms of the business context, I mean, this is not really a business, but this is where you need to know about the problem that you're solving and what question you're trying to answer. Right. So let's go into a little bit of the math here. Okay. Um, let's step away from the vaccine and take a really simple example of tossing a coin. So you have a fair coin. What I mean by fair coin is that there is a 50% chance that it'll, when you flip it, you'll get a heads, and there is a 50% chance that you'll get a tail when you flip it. Now let's take this really fair coin and toss it 100 times. So when you do that, uh, so let's do this exercise in our minds. Right? Uh, how likely do you think that we will get 5 heads and 95 tails when we do that? Right? I mean, it's a fair coin, right? So, I hope no one is surprised when I say that it's a really, really small number. It's 6 into 10 power minus 23. Now let's use a slightly different example. what do you think is the probability that we'll get exactly 50 heads and 50 tails, right? The keyword there is exactly 50 heads. And again, I hope you're not surprised by this. There's only a 8% chance, right? A probability of 0.08 that you will get exactly 50-50. And I really hope that doesn't surprise anyone because, and I hope that the next slide clarifies that. Now, let's look at it in a slightly different way. What do you think is the probability that you'll get, somewhere between 45 and 55 heads and 45 and 55 tails? This is where we start seeing a higher percentage of. So actually, when you do the calculation, it comes out to be about 68%, right? And if you think about it, it kind of makes sense, right? Like even if you were to toss a coin twice, it's not like you're going to get one head and one tail. There is going to be some probability that you'll get both heads or both tails. So when you do it over a span of 100 times, it's actually quite unlikely you get 50 heads and 50 tails. But if you were to look at it as a range of between 45 and 55, that's where you get a higher number. Now, this is the last example I have where let's say you are looking at 40 to 60 heads and 40 to 60 tails. This is where the number gets really high and you get a 95% chance of that happening. So I hope that all of this makes sense to everyone and it's not too surprising because we'll go a little deeper with this. So here's actually the formula to come up with these probabilities. I don't know how many of you remember this from learning probability in your schools or in your college, but this is actually the formula. It's the formula for a binomial distribution, right? And again, I don't want to go into the formula itself, but something that data scientists like to do is when we come across a formula like this, we like to draw charts with this, right? And this is what a probability distribution looks like. Now, we refer to this as a bell curve because it kind of looks like a bell. And one of the favorite charts for a data scientist, and I can only imagine how intimidating a chart like this could be to someone who doesn't have a background in data science. Right? So fear not, I'll explain a little bit about this, and I hope that it makes sense at the end of it. Now, the x-axis here just shows the number of heads, right? So from our previous example, if you remember, probability of getting exactly 50 heads, that's represented by this bar here, and that's 8%. Probability of getting 5 heads, where if you remember, it was like 6 into 10 power minus 23, really small number, right? You can't even see it in the chart here. So that's what is there here. Now the benefit of having such a chart here is, you can very easily find out what the probability is for any outcome. So to get 44 heads, it's actually 4%. To get 53 heads, it's 7%, and so on. Now, when it comes to the other example that we saw of getting between 45 to 55 heads, there's a 68% chance, right? Now, for that, it's actually what you the way you can calculate that with this chart is you can look at this area represented here between 45 and 55, right? And the proportion of the area here compared to the entire chart, that's going to be the probability of it being 45 to 55, and that's 68%. Here's the same thing when you look at it for between 40 and 50, or 40 and 60, and that the area covered here represents 95% of the chart, and that's why it is 95%. So, and I hope even this, that makes sense now. Now, let's make it a little bit more interesting. Right? So imagine that you have a biased coin. So the probability of getting a head here is 75%, and the probability of getting tail is 25%. Right? So you're more likely to get heads than tails with this other coin. If you do the same exercise and build that chart here, this is what it looks like. Again, I hope, and again, you see that it's not too different, right? The only thing here is the bell curve is slightly shifted towards the right, the shape still remains the same. I hope that didn't surprise anyone, because again, there's a 9% chance that you will get exactly 75 heads, 6% that you will get exactly 71, 3% that you will get exactly 82, right? Because, and all you need to know here is, with the 75% bias coin, it's going to be centered around getting 75, exactly 75 heads. Again, you can do the same thing and figure out what is the probability of getting anywhere between 65 to 85 heads. That's going to be 95%. Okay. Now, finally, actually, this is the last bell curve chart I have. So imagine, we have three coins now, right? So we have a coin which has a 25% bias for heads, a 65% bias for heads, and a 75% bias for heads. And this, and if you were to overlay all of them, this is what it looks like, right? Like the purple one here shows the probability distribution of a 25% coin, where you can see it's all centered around the 25 mark. The red here represents the 65% bias coin, and everything is centered around that 65 mark. And the 75% bias coin is centered around the 75% mark. Now, before I go back into the vaccine data, let's take away some key things from here, right? The first thing is, you can determine what the bias is based on the probability, just based on the positioning, right? Like as the bias for a certain event increases, you see that move accordingly in the chart. So the 25% bias coin is on the left hand side, 75% bias is on the right hand side, right? And as you move towards more and more bias, it moves towards the right. The second thing that I want to point out here is that, if you have a 75% bias coin and your friend has a 65% bias coin, and you both toss it 100 times, there is going to be a really small probability that both of you will get the same number of heads. And that's what is represented by this overlap here, right? So if you look at this number 69, right? I mean, you can imagine that a coin that has a 65% bias could also get 69 heads, and a coin with 75% bias, when tossed 100 times, you could get 69 heads. And both of you are getting the same 69 heads, but we know for a fact that both the coins have different bias. Right? So because they have such close bias, you will end up getting a similar or the same result. And that is something, again, you can go ahead and calculate what that probability distribution is, or what the probability of that happening is. However, when it comes to the difference between this 20, let's say you have a 25% bias coin and your friend has a 75% bias coin, it's extremely unlikely that you will get the same number of heads when you both toss the coin 100 times. And that's all you need to know before we go back into the vaccine data. Right? So let's go back to the vaccine data, and we can, now that you know the concept of these, how we can use these probability distributions, let's convert this vaccine data into that example, right? So imagine, instead of participants, it's the number of, you're tossing the coin 21,000 times, and instead of counting the number of heads, you're counting the number of people who got infected. So you change that formula that we saw earlier from, use the number of, instead of coin tosses, use the total participants, and the probability of getting one heads, change that to probability of someone getting infected, right? And we know from this calculation here that the probability of someone who got the placebo getting infected is 0.77 divided by 100, and probability of someone getting the vaccine after they got the probability of someone getting infected after they got the vaccine is 0.04 divided by 100. So once you have these probabilities, you can go ahead and draw a similar chart. And this looks awfully similar like what we saw earlier, right? Between the 25% bias and the 75% bias. And because it has no overlap, we can be fairly confident that this is kind of like how it's like tossing a 25% bias coin and a 75% bias coin. And what is the probability that they will both have the same outcome? That's, and if you translate that here, all it shows here is that uh, the vaccine and the placebo are very different from each other. And the vaccine, given the position of it on the chart, we know that the vaccine is way more effective than the placebo. Now, that's a, and it's okay if you're still confused by all of this, because people spend entire semester taking a course in hypothesis testing and still find a hard time figuring out what this is. But I hope this gives you an idea of what a data scientist does. Now,
Yes.
to be honest, uh, it's extremely unlikely that Pfizer actually hired a data scientist to do all of this. The scientist who created the vaccine probably knows the math to do all of this. However, uh, companies do use hypothesis testing in real world. So something that I have personally worked on, again, because of an NDA, I cannot disclose which company that is. But imagine there is this web streaming company called Webflix, and they might want to figure out what is the likelihood that someone might or what is the effectiveness of giving out a free 1 week trial, right? So what they could do is they could send out emails to, they could first identify about 5% of their customers. About half of that 5% would get a email that just says buy subscription, right? Or you could actually you could do it to people who were your customers in the past, but they have canceled their subscription. You could identify a small proportion of them and send half the people an email that has a lot of content, but at the end of the day, it has a link to buy subscription. To the other half, you could send a email that just says start free 1 week trial, and then after the 1 week trial is when they would start the paid subscription. Now, a data scientist at this company would look at the subscription rate of both of these populations. So they would look at how many people uh, got their subscription by just clicking on the buy subscription button, what percentage of the people got it that way, versus in our treatment population, how many got the subscription after getting the 1 week trial. And then you can compare the two of these and figure out whether the 1 week trial was indeed effective in winning back customers or not. And then you could do a deeper analysis and find out what was the cost of this 1 week trial, and how long it would take for the company to get profitable after that 1 week trial. Another example here would be, imagine there's a data scientist at a um, e-commerce website, and now that e-commerce website needs to decide whether what kind of shipping options they should have on their website. Right? So they could do some kind of an experiment here where they give half the customers two options, one being free shipping, the other one where you pay 100 rupees and it arrives tomorrow. And you could give the other half of your customers two different options where you offer free shipping which arrives in 1 week, or you pay 50 rupees and it arrives in 3 days. Right? Now, the reason why this is important is because as a company you need to think about how you operate your shipping supply chain, right? You need to have a different type of infrastructure to make sure that your customer receives the product tomorrow versus they will receive it in 3 days, right? And there's a cost implication for both of that. Now, you could say, well, the company could do both, but there's a cost implication to doing both, right? So they need to figure out which one is likely to be more more helpful to the customer, which one the customer would prefer better. So they could run this experiment where half the for a week or so, where half the people get this 100 rupee option, and half the people get the 50 rupee option, and then they could then look at all of the data and figure out which one is more profitable, which one gives the customer a better experience, and all of that with the data. So that's how the same concept that was used to figure out the difference between the 25% bias coin and the 75% bias coin. The same mathematics that goes into figuring out whether the vaccine works or not can then be used to figure out whether a free 1 week subscription works or not, or what kind of shipping decisions the corporation should have. So that's some a very high level overview of hypothesis testing. A couple other things that I want to talk about is machine learning and forecasting. Again, because of my NDA, I cannot really disclose what projects I worked on. But I'll go a little deep into what machine learning is for anyone who doesn't know. So, as the word sounds, word says, machine learning is essentially, a process in which you are teaching the machine something, and the machine is essentially, your computer. So you're teaching the computer to do a certain process again and again and again. So let's look at this really simple example where you want your computer to identify which photo is the photo of an apple, which photo is the photo of a banana, and which photo is a mango. Right? And you do this by providing the computer or your server with a huge number of examples of what an apple looks like. Right? You will take thousands of photos of apples from many different angles and feed it to the computer. You'll take thousands of millions of photos of bananas from many different angles. You take ripe bananas, you take unripe bananas, you take maybe half-eaten bananas, you take someone eating a banana, you take all of these photos, feed it to your computer, and same thing you do with mangoes, right? And then that is where a data scientist would come in and essentially teach the computer to identify the difference between apple, mango, and banana. And now these teaching algorithms, they are heavy in math. The formulas would not fit in a PowerPoint, so I have not showed them here. However, you should be able to learn more about these by just doing a Google search about machine learning. And once the computer is trained on it, you can load a image that of an apple, and the computer will be able to identify, actually, yeah, this is an apple and this is a banana. Now, that's a really simple example with fruits. But if you take it a step forward, you can do this for a number of things, right? So again, imagine that you're an e-commerce website. The e-commerce website has a lot of data around, who is likely to make a purchase and who is unlikely to make a purchase. And they do this by looking at, what was the behavior of people just before they made a purchase, right? And you can algorithmically figure out what are the things that someone does before they make a purchase, and what are the things that stops them from making the purchase at the end of the day. So using these algorithms, you can push someone towards making a purchase. Again, the same algorithm can be applied to figure out who is likely to get sick. So imagine that you are a health insurance company and you want your uh, members to not be sick, right? Because when your member gets sick, you have to pay their hospital bills. So you want to make sure that your members do not get sick, so your company is more profitable. So in that case, again, right? So again, because in the US, all the medical data is computerized, these algorithms can be used to figure out, who is likely to get sick. And before they get sick, the health insurance company themselves will, point you towards material to make sure that you don't get sick. So examples for that is someone who has diabetes and is also smoking. They will send out, materials and discouraging them from smoking, because if they get sicker, the health insurance company loses more money. So that's an overview of machine learning. So the last example I have here is called time series forecasting. This is, I would say, simpler than machine learning because it doesn't really need a lot of input. This is something that needs very less compute power compared to machine learning. All it does is, we are looking at a history of sales and figuring or making a forecast of what the sales are going to be in the future, right? So imagine you're working at a electronics company. Year over year, you're going to see an increase in sales, and you're also going to see a spike in sales around Diwali every year, right? And hopefully, you see these seasonal spikes here, right? Now, a data scientist could use all of this data to figure out what is going to be the sales for next year. And once we have that prediction, the company can then figure out they can use that forecast to make a number of decisions, right from how to manufacture their products, how to source the materials for their products, how to distribute their products across the country, and all of that, right? Like you could look at all of that history of sales, build algorithms that create a forecast, and use that forecast to make inform a number of decisions in your company. At the end of the day, you want to make sure that your products are at the right place and at the right time, and forecasting helps with that. So these are some really really basic examples of data science. And I hope I got you interested in this topic. So the last couple of last slides that I have here is, if you take away anything from this, in terms of what a data scientist does, we use a combination of computer science, information technology, math, and knowledge about the business to help the corporations make decisions based on data. In terms of how we do it, yes, that is true. We do, use machine learning, neural networks, image processing, applied mathematics, deep learning, and all of that. And I'm sure I'm missing out on a few. And I'm sure that if you, were to revisit this in a couple of years, there would be more things added to this as well. Um, so I hope you're interested in data science with my talk, and I still want to leave you all with a few bonus takeaways that has nothing to do with data science. I felt obliged to do this because I've been out of engineering college for about 10 years now, and these are some things that I hoped someone told me when I was still in college. So the first, advice I have for all of you is to exercise. Right. So all of you, I'm guessing, are either in your early 20s or late teenage and like I'm guessing all of you are in that 19 to 22, 23
Yes,
years old.
19 and 20.
Okay, yeah. So
Yeah.
this is something I wish I knew. Well, I'm 31 now, so this is something I wish I knew 10 years ago. The importance of exercising. All of you guys will soon have corporate jobs. You will be sitting at a desk for a really, really long time, and that is going to have a influence on your mind as well as your body. Exercising every day is going to help with both. And when I say exercise, I don't mean you should go to the gym or you should lift dumbbells or you should do this or you should do that. Any physical activity, right? Going for a run, going jogging, just walking, anything. But make sure you get your heart rate up. By doing exercise, that's really good for you. The next thing I have here is to eat healthy. Again, like I said, most of you are going to have corporate jobs which require you to sit at your desk all day. And you're likely going to skip breakfast. You're going to have a really unhealthy lunch at work, and you're going to go back home and eat something like Maggie. You're going to order from fast food and stuff. Again, your bodies are not going to like that, although your tongue might. But make sure you eat healthy. This is something I wished I knew back when I was in college. It's Again, when I say eat healthy, I'm not really making a recommendation on what you should eat. Uh, you know, you could have your own dietary preferences. You could eat meat. You could not eat meat. You want to drink milk. You there are irrespective of what your dietary preferences are, it's very not easy, but you if you put a little bit of effort, you can figure out what is healthy and what is not. So make sure you do that once you get out of college. So the last thing I have here is about money, right? Again, I think in a couple of years, a lot of you are going to make a lot of money. Make sure you learn about money. Again, I don't want to make any specific recommendations around what to do with your money, but be mindful of it. This is, the first time you're going out and making money for yourself. Money, the world we live in, money is a really important part of our lives. And the sooner you make the right decisions about money, the better off you will be in the future. So I hope, you guys, even though you don't relate to it, 10 years later, you might look back and see, Acha, all of this makes sense, and I wish I followed that. So I hope you're not in that situation and you take this advice really seriously. Okay, so this is the last slide I have. I want to thank everyone for listening in, um, and everyone at Taqneeq and at your college for hosting me. So I want to leave you with just a couple of things here. So I'm really active on Twitter. You can follow me on at graph and graphs and charts. You'll find something interesting there. Make sure you follow me there. You can also reach out to me on LinkedIn. You can just go search for my name, and you should be able to find me relatively easily. So having said that, I will open up the floor for any questions you guys might have.
Yes, sir. So first of all, thank you so much for this really informative session. It was like great to hear so much. Actually, we have this field, the data science field in our
Okay.
college, like
Okay.
BTech with specializations in data science. Also, we're having this course in collaboration with IBM, that's data
Mhm.
analytics. So
Okay.
it's actually opening up a lot of opportunities for us as well
Oh,
to
that's
enter
great.
into the field of, yeah. So, and apart from that, so some students had the questions like, what can they do to pursue a career similar to yours?
Mhm.
It's like
Yeah.
data science is a blooming field, so it's like it's there to offer us a lot of opportunities in the future. So
Yeah.
yeah,
I say, the way I got into data science is completely random. Just fortunate to get into a company like Mu Sigma because
yeah,
I don't think in 2011 there was even a word called data science, right?
yeah, true.
So when I joined Mu Sigma, I did not know what it is. Because I just wanted to get a job, and Mu Sigma was one of the first companies to come to my college. I got the job, and because of the rules in my college, I couldn't sit for another placement.
Hmm.
So I was kind of forced to join Mu Sigma. But I think that was one of the best decisions I made. Now coming, I think in 2021, there are so many opportunities for you to start a career in data science, right?
Yes,
I think even for someone who is not in the data science field right now but wants to make the switch, I think one thing you can start is by taking online courses. I'm sure I don't know what specific courses are available in India, but I'm sure there will be many online courses available, right?
yeah,
So you should be able to learn R or Python um, on from these online courses, and I think for an entry level job, that's all they're looking for. They are likely looking for some knowledge about probability and statistics. So yeah, so learn a little bit about it, a little more than what I presented today.
yes,
And yeah, learn Python and R. In terms of the business knowledge, again, you need to learn that no matter which field you are in, right? So and I believe that is not something most companies are expecting you to know about. Make sure you know a little bit about the company that you're interviewing for, but in terms of what business they do, how they make money, all of that, try to know a little bit about that. But it would be okay for you to not know it. But I think as soon as you join a company, I think to set yourself up for success, more than give more importance to learning about the business of your employer than you do about writing some fancy algorithm. So yeah, so in terms of advice of what you could do, yeah, take these online courses, apply for companies. I'm sure there are many companies that do data science in India right now.
yeah,
And there are there's this website called Kaggle where you can
yes, sir.
fit in competitions. Having that definitely helps set you aside from other people applying for the same job. So yeah, you could do all.
Kaggle is a lifesaver, so for all us engineers, it's a lifesaver.
Okay.
Getting all the codes from there, copying, pasting it.
Yeah.
That's all we used to do.
Yep.
Yes, sir. So we also had another question.
Mhm.
So who do you admire the most in the data science community?
Who do I admire the most? I think one
Yeah.
person I really admire is Dheeraj, who's the CEO and the founder of Mu Sigma.
Oh,
I mean, I definitely I'm in this career only because he started that company, so I definitely do admire him. There are many other people who don't really do data science, but they have used data science to make themselves better. So I think a really good example of that is the former U.S. President Barack Obama. So when he ran for his 2008 campaign to become the president for his first term. He was one of the first, I think, one of the first politicians to use data and data science to inform his decision making during the campaign. Now, I think pretty much every politician does that. But Obama, I think, at least some part of his victory has to be attributed to using data and machine learning and data science.
That's great, sir. And talking about people, I just wanted to like inform you, like the first speaker we had,
Mhm.
uh, Mr. Sandeepan Das, he is a scientist in ISRO. So he's
Mhm.
also from NIT Durgapur.
Oh, he is.
So yeah,
Oh, okay.
so I thought like you guys might have a lot of memories in common.
Oh, yeah.
So
I'm sure.
yeah, yes, sir. So I have one more question about your career in particular, is that what in your career are you most proud of?
I think so. There's an NDA that I have an NDA, so I can't really talk too much about the project itself. But I
Yeah.
say I'm most proud of my work that I've done for the health insurance company here in the US. Uh, so,
Okay.
um, so the health insurance company that I work for, really short time, less than a year. But I think my most impactful work was done at that company because I mean, yeah, at Microsoft, you're helping people sell software. At Nike, you're helping people buy shoes. But when you're working at a healthcare company, health insurance company, you are ensuring that healthcare goes to the right people. So I think that was that. I'd say I'm most proud of that work.
So there was a fun question asked. What's your favorite data structure?
Favorite data structure. I'll tell you what is my most least favorite data structure because yeah, I think that's an easier question to answer. The least favorite data structure. I'd say dates. I hate working with dates. Dates. Uh,
Okay.
yeah, so I hate working with dates. When you move a data from one particular platform to another, dates are the first thing that gets messed up. The way the dates are formatted, all of that, man. Yeah, I spent a lot of time debugging dates. So yeah, that's my least favorite. Favorite, I mean, I don't know. I think anything but dates. I would say, yeah, I'm okay with that.
That's good. So you really enjoy what you do. That's really good.
Yeah.
But yeah, it's like nowadays, like whoever I talk to, any senior or any, mentor of mine, so everyone is like, dude, go for data science. Go for it. Just go for it. No second doubts to it. It's like such a blooming field, and like I'm sure like students would have like learned so much from it. And then again, it's not that difficult if you like, have a good understanding of concepts.
Yeah, hey, at the end of the day, you need to make decisions, right? Like no matter who
Yes,
you are or
that's
what,
what.
you need to make decisions, and the business of data science is to help make decisions. So yeah,
Yes. You must implement all of this so much in your personal life as well, right?
not really. I mean, you could, right? Like for example, I use a Fitbit tracker.
Yeah.
So I look at all the data, like how long I sleep, how many steps I take, what is my heart rate, all of that. I mean, I don't know if it's because of my career in data science or, Fitbit is really a good company and they provide you with a really nice UI. But yeah, you know, at some point, you start looking at all of this data and try to make sense out of it.
Yeah, no, sir. It's just because you are into data science and all.
Yeah,
That just comes to you naturally.
perhaps, yeah.
Yeah, sir. And also, one question was asked, what makes you, sorry, what makes a good data scientist according to you?
Yeah, I think a really good data scientist, before they, you know, people are going to come and ask you to do things. Like when you are a data scientist in a company, people will come and ask you to, instead of telling you what the issue is or what is the problem they're trying to solve, they will go and read some blog about data science or they will watch a video about data science and they will formulate the solution in their mind and they'll come to you and tell you, okay, use this data, use this, and I want this. um, and it's really tempting to just follow what they're telling you to do because they're telling you what to do. All you need to do is write some code to make that happen. And at in the beginning it might seem really challenging, but at some point, writing code is not that challenging. So you're like, yeah, okay, yeah, I'll do this, and I'll give you this. But I think a really good data scientist will not worry so much about the code and jump into coding, but would go back to your colleague or your stakeholder and ask them, like, why do you want this? Like, what is the actual problem you're trying to solve? And then understand what that problem is and work with them, brainstorm with them, and figure out what the appropriate solution could be. um, and and I tell you, most of the times what they really want and what they tell you they want is completely different. So if you focus on what they want instead of what they tell you they want, I think that is what makes a really good data scientist.
That's great. And so, like, one question was asked. This is the last question actually from the whole list.
Okay.
Like you said that you joined Music Mom and it was like in the blooming stages. It wasn't
Mhm.
that famous.
Yeah.
And now you're working in a huge company, Nike. That's
Yeah.
like, wow. So what would you recommend? Like we as freshies or like anything, should we join like, a startup or like a big company?
Uh,
So like what's more beneficial for us?
I think given my background, I will definitely, I have a bias for startup. So
Yeah.
so here's the thing, right? So if you're working at a startup, you're going to learn a lot, right? So you're going
Yes.
to learn things about data science. You're going to learn about the company. You're going to learn so many different things. Um, However, it's unlikely that your pay is going to be, competitive. And I'm sure Music is still in that phase. I don't know. I don't know. Maybe they've changed now. But when it comes to an established company, it's unlikely that you will. I mean, you could still learn a lot of things, but the rate at which you learn things, the rate at which you do new things, is going to be lower. Uh, well, your pay is going to be significantly higher than a startup, right? So again, it's your own decision, but at the earlier stages of your career, I would say you don't worry too much about the money and focus more on learning new things, and at some point all of that is going to pay off, right? Like when you learn new things, the big companies are going to come looking for you. So
Yes.
definitely my bias is towards at least the earlier stages of your career to join a small company where you're going to learn a lot of things, and at some point in the future, you either go back to college for masters, be it in India or somewhere else in the world, and then move to a bigger company or directly move to a bigger company.
Yes, sir. And so, like, regarding this only, like, what do you think is more better? Like, a company of your choice. Like, for example, I have this XYZ company. That's my dream company. I
Mhm.
have to get there. But I also have this ABC dream job, this
Mhm.
position. So, what do you think I should prefer more? Like, I'm getting this position somewhere else,
Mhm.
and I'm getting this company, but with a much lower position. So,
Yeah.
what do you think I should go for in this situation?
So I think, so again, from my experience, what I've noticed is that you might have a dream job, you might
Yeah,
you could have all of that, but you don't really know how it's going to be until you join. Like, there's no way for you to know, no matter which company that is or which position that is,
that's true.
be it data science or not. the, there is no way for you to actually know how it is going to be after you join the company, right? So take that out of your decision making.
Okay.
When you're making a decision, make it on things that are clear and are that you can completely rely upon. Like, what is the location of the job? What is the pay? What is the designation? And what is the company overall? Right? Don't think that there's this data analyst position in this company and there is a data scientist position in this other company. Which one should I
Yeah,
pick? Because it's highly likely that at a data scientist job, a lot of your work is going to be data analyst work, whereas in a data or the vice versa, right? Like, where your designation is data analyst, but you might end up doing a lot of data science work, either right now or within 6 months of joining that role, the priorities change, and then you start building machine learning models, right? Like, so if you're choosing between data analyst and data scientist, I would say don't go behind the designation, because at the end of the day, the core job of both is going to be very, very similar. Make your decision on other things.
Got it. Yes,
Does
yes.
that answer your question, or were you asking me something different?
No, sir, that's exactly what I asked. Yes, sir. So the questions are it from our side. So you want to share anything with us?
No, I think I spoke a lot.
Yeah, a lot.
Exercising, eating healthy, and learning about money. That's all.
Three bonus takeaways.
Yeah.
We'll definitely keep them in mind. Yes, sir. So thank you so much for being here, for giving us your time.
Yeah.
Even despite of the time difference, the huge time difference we have,
Oh, no
still you
problem. Just
made time for
Friday,
us.
Friday evening in COVID right now, so there's nothing else for me to do.
That's different, but yeah, so thank you so much. Like it was a really informative session. I'm sure like the students, the viewers got a lot out of it and then would definitely think towards, getting a career in this field itself.
Okay.
And yes, sir. So
Yeah. Thank you
I
for
want to
having me.
thank you so much, sir. It was a pleasure having you.
Cool. See you.
Yeah. Bye, sir. Thank
Bye.
you.